Lap 1, your agent was sharp. Read the task, made a clean plan, shipped a perfectly reasonable change. Lap 40? Now it's rewriting code it already fixed. It's apologizing to itself in the comments. It's confidently putting back the same bug it solved on lap 12. And here's the part that should bother you. Nothing about the model changed. Same weights, same temperature, same everything. So, what got dumber? That's the whole question for this video. Quick honesty note before we go any further. This is Neural Stack's working analysis. It's a mental model we actually use, not a benchmark study. But stick around, because by the end you'll know exactly where the rot gets into a loop, why that verifier you bolted on can't stop it, and what a loop that stays sharp actually looks like. Okay, let's get concrete about what a loop actually is. Every lap, most agent loops do the same basic thing. Take everything that's happened so far and append more to it. The original task, the agent's plan, the tool output, the diff, the test failure, the retry, the next plan. All of it lands in one growing transcript, and that transcript is the loop state. It's the working memory the next lap inherits. Now think about what that transcript is actually made of. Success exits the loop. Failure is what loops. So the history a long-running loop piles up is, structurally, a museum of dead ends, abandoned plans, stale error messages, patches that got reverted, conclusions that turned out to be wrong. Lap 4 inherits a crisp task description. Lap 40 inherits that same task description buried under 39 laps of its own thrashing. The backpack only gains weight, and nobody ever scheduled anyone to unpack it. And here's why all that accumulation isn't just clutter, it's steering. To a language model, everything in the context window is signal. It doesn't tag old content as expired. That plan from lap 9 you abandoned, still in there, still reading like intent. The error message from a version of the file that doesn't even exist anymore, still in there, still reading like a live problem. The agent's own confident but wrong analysis from lap 15, still in there, and now it's evidence the agent cites to itself. This is the core frame for the whole video. The loop doesn't degrade because the model gets worse. It degrades because the prompt gets worse. Every lap, the ratio of live signal to dead noise slides a little further toward noise. The agent on lap 40 isn't a dumber model. It's the same model, reading a much worse briefing. Now, if you watched our video on building the judge first, you might be thinking, hang on, I solved this. I put a verifier in the loop. Nothing ships unless it passes. And look, that's genuinely worth doing. But watch what the judge actually fixes and what it doesn't. A judge is a filter on outputs. It catches the bad patch on lap 39 and rejects it. Great. But then what happens? That rejection gets appended to the transcript, and lap 40 begins, produced by an agent reading everything lap 39 read plus one more failure. The judge repaired nothing about the state. And by our analysis, it can actually make the dynamic worse in one specific way. Every rejection is one more lap, and every lap is more accumulation. So a perfect judge attached to a rotting context gives you a loop that reliably refuses bad output, while getting progressively less capable of producing good output. You built a bouncer. The problem's inside the building. So why should you care if you're not building agent frameworks? Because this is the shape of the workflows people actually run. That overnight run you kick off before bed, iterate until the tests pass. The autofix loop wired into CI. The keep going until it's done session you leave unattended. And the trap is that every individual lap looks like progress. There's a fresh diff. There's activity in the log. The loop never announces that it started orbiting. You find out the next morning when you read the transcript and realize the last 30 laps were the agent fixing, unfixing, and refixing the same 3 files, spending more effort per lap on less progress, precisely because each lap had to wade through more history just to find the task. That's the invisible bill. It's not just the compute. It's the night you can't get back, and the branch you now have to untangle by hand. So what do you actually do about it? And this part is explicitly our take the channels interpretation, drawn from the mechanism we just walked through. If accumulation is the disease, then the design goal is a loop that manages its own memory. There are three shapes we think about. 1. Reset. Start each lap with a fresh context that carries only what's actually live, the task, and the current state of the work. The repo already remembers everything else. The transcript doesn't have to. 2. Summarize. If your laps genuinely need history, checkpoint it. Compress what's been learned into a short brief and let the next lap read the brief instead of the raw scroll of failures. Curation, not accumulation. 3. Fork. Instead of one long thread grinding forward, branch clean attempts off the last known good state and keep whichever one lands. And the early warning signs that your loop is already rotting? It redoes work it completed. It contradicts decisions it already made. Its output gets longer while saying less. And yes, it starts apologizing in the comments. So let's close the loop we opened. Lap 1 was sharp, lap 40 was senile. And now, you know what actually got dumber. Not the model. The model never changed. What degraded was the input. 40 laps of accumulated noise, fed back in as if it were all still true. The agent didn't lose capability. It lost a clean view of the problem. And the fixed version of that same overnight run? Each lap wakes up to a short current brief. The task, the state, the 1 or 2 lessons worth keeping does its work and hands forward a clean summary instead of a longer scroll. Lap 40 reads almost exactly what lap 1 read. Same model, same sharpness, 40 laps in. Iteration was never the problem, inheritance was. All right, here's what I want from you. What's the longest agent run you've ever let rip? And where did it go sideways? Drop it in the comments. The lap count, and the moment you realized it was orbiting instead of progressing. Those stories are exactly the material we want to dig into. And if you haven't seen it yet, the companion piece to this one is Build the Judge First. Not a rerun of this argument, the other half of it. This video is about keeping the agent capable. That one's about verifying what it produces. You want both. Subscribe if you want the next layer of the stack. See you on lap 1.